In the vast, silent expanse of our cosmic neighborhood, one world stands out as a true masterpiece of planetary architecture. It is the sixth planet from the Sun, a colossal sphere of turbulent gas wrapped in a halo of dazzling light. This is Saturn. Known to ancient astronomers who tracked its slow journey across the night sky, Saturn has captivated human imagination for millennia. To early stargazers, it was merely a wandering star. But modern science has revealed a world of unimaginable scale and staggering beauty. Saturn is the second largest planet in our solar system, a true giant. It is a world so immense that over 700 Earths could easily fit within its boundaries. Its diameter at the equator stretches nearly 75,000 miles. Yet, despite its mammoth size and overwhelming gravity, Saturn is surprisingly ethereal. It holds a unique record. It is the only planet in our solar system that is less dense than liquid water. If you could somehow find a cosmic ocean large enough to hold it, this magnificent giant would simply float. Situated roughly 900 million miles away from the Sun, Saturn dwells in the deep freeze of the outer solar system. Here, sunlight is but a distant, pale glint, providing only a fraction of the warmth and light we experience on Earth. But even in this twilight realm, Saturn shines with an unmatched brilliance, an ethereal beacon in the dark. Welcome to a journey into the heart of a giant. This is the story of the jewel of our solar system. To truly understand Saturn, we must first peel back its serene, butterscotch-colored layers. Unlike rocky, terrestrial worlds such as Earth or Mars, Saturn lacks a solid, tangible surface. It is a gas giant composed overwhelmingly of hydrogen and helium, the exact same primordial elements that fueled the birth of our Sun and the ancient universe. If you were to attempt a descent into Saturn, you would never find a solid place to land or stand. Instead, you would sink endlessly through progressively denser layers of swirling, noxious gases. You would plunge through clouds of ammonia ice, then ammonium hydrosulfide, and finally down into clouds of water. As you descended deeper, the atmospheric pressure would become crushing, and the temperatures would sear at thousands of degrees. Eventually, deep within its core, the pressure is so absolute that hydrogen gas is compressed into a bizarre state of matter known as liquid metallic hydrogen, a conductive fluid that generates the planet's immense magnetic field. Saturn's calm exterior is an illusion, masking a highly turbulent and violent atmosphere. It is a realm of ferocious, unending weather. Equatorial winds howl at staggering speeds of up to 1,100 miles per hour, more than 4 times faster than the most destructive Category 5 hurricanes on Earth. High above the planet's North Pole lies one of the most mesmerizing atmospheric features ever discovered, a massive, persistent hexagonal storm. This geometric marvel, large enough to swallow multiple Earths entirely, is a swirling vortex of jet streams, a testament to the complex and chaotic fluid dynamics that govern gas giants. While its atmosphere is a storm-ravaged chaos, Saturn is defined by a structure of unparalleled elegance. No feature of this planet is more iconic or more breathtaking than its majestic ring system. While other gas giants in our solar system, Jupiter, Uranus, and Neptune possess their own rings. Absolutely none rival the size, complexity, brightness, and sheer visual drama of Saturn's. Stretching outwards into space for hundreds of thousands of miles, yet incredibly, astonishingly thin, often measuring no more than 30 to 50 feet in thickness. The rings are a cosmic optical illusion. When viewed from afar, they appear as solid, concentric tracks, but they are not solid at all. The rings are composed of billions upon billions of individual particles, trapped in a delicate, endless gravitational dance around the planet's equator. These particles range in size from tiny, microscopic grains of dust to massive boulders the size of houses and mountains. They are almost entirely composed of pure water ice. It is this incredibly high ice content that makes the rings so highly reflective and brilliantly visible from Earth. But where did this spectacular halo come from? Current scientific theories suggest the rings are the shattered, pulverized remnants of ancient comets, asteroids, or perhaps even a doomed, icy moon that strayed too close to Saturn and was violently torn apart by the planet's immense tidal forces. Look closely, and the rings reveal a highly structured, almost architectural nature. They are divided into thousands of individual, distinct ringlets separated by wide gaps, most notably the prominent Cassini division. These empty gaps are not a coincidence. They are constantly cleared and maintained by the gravitational influence of tiny, hidden shepherd moons. Saturn is far more than just a solitary planet. It is the gravitational anchor of a bustling, dynamic miniature solar system. Beyond the shimmering edge of the rings lies a sprawling family of natural satellites. At last count, Saturn boasts over 140 recognized moons, each possessing its own unique history and geological story. Among this vast retinue, 2 moons stand out as prime targets in humanity's ongoing search for extraterrestrial life. The first is Titan, Saturn's largest moon, and the second largest moon in the entire solar system, larger even than the planet Mercury. Titan is a bizarre anomaly. It is the only moon known to possess a dense, nitrogen-rich atmosphere, which is actually 50% thicker than the atmosphere we breathe on Earth. Beneath its opaque, orange photochemical smog lies an alien, yet eerily familiar landscape. Titan is the only other world we know of that features stable, liquid bodies on its surface. However, these are not lakes and seas of water, but of liquid methane and ethane, sustained by a freezing, cryogenic weather cycle of hydrocarbon rain. Equally compelling is the much smaller moon of Enceladus, encased entirely in a shell of brilliant, highly reflective white ice. Enceladus was long thought to be a frozen, geologically dead world, but recent exploration has revealed a staggering reality. Enceladus is alive. Massive, powerful geysers erupt from deep, tiger-striped fractures at its south pole, blasting colossal plumes of water vapor, ice crystals, and complex organic molecules directly into the vacuum of space. This breathtaking activity points to one undeniable conclusion. Beneath the icy crust sloshes a vast, warm, global ocean of liquid water. Much of what we now understand about Saturn, the intricate dynamics of its rings, and the profound mysteries of its moons, we owe to one of the most ambitious and spectacularly successful scientific endeavors in human history, the Cassini-Huygens mission. Launched in 1997, this international joint venture between NASA, the European Space Agency, and the Italian Space Agency represented a pinnacle of global cooperation. The spacecraft took 7 long years to traverse the interplanetary void before finally executing a flawless orbital insertion around Saturn in the summer of 2004. For 13 incredible years, the Cassini orbiter served as humanity's robotic eyes and ears in the Saturnian system. It captured unprecedented, breathtaking high-resolution imagery that fundamentally changed the textbooks on planetary science. It carried the European-built Huygens probe, which in early 2005 achieved a historic milestone by descending via parachute through Titan's murky alien atmosphere. Huygens successfully touched down on Titan's freezing, squishy surface, capturing images of rounded ice cobbles, marking the most distant landing ever accomplished by a spacecraft from Earth. Cassini observed the slow changing of the seasons on Saturn, watched colossal storms erupt and fade, and made the groundbreaking discovery of the subsurface ocean on Enceladus by boldly flying directly through its towering water plumes to taste the alien ocean. By 2017, after fundamentally rewriting our understanding of the outer solar system, Cassini was finally running low on rocket propellant. To strictly protect the pristine, potentially habitable environments of Titan and Enceladus from any accidental contamination by resilient earthly microbes, mission scientists made a dramatic, irreversible decision. Cassini would embark on a final, daring phase aptly named the Grand Finale. Over several months, the spacecraft executed a series of unprecedented, heart-stopping dives in the narrow, unexplored gap between the planet's upper atmosphere and its innermost rings. Finally, on September 15, 2017, Cassini intentionally plunged deep into Saturn's crushing atmosphere. It fought to keep its antenna pointed at Earth, beaming back invaluable, final data about the planet's atmospheric composition until the very last second, when it burned up like a brilliant meteor in the alien sky. Cassini is gone, now forever assimilated into the very giant it studied so intimately. Yet, the legacy of Saturn remains stronger than ever. The mountains of data collected by the mission will keep scientists and researchers busy for generations to come. Saturn is not merely an object of immense visual beauty. It is a vital, active laboratory for understanding exactly how planets form, evolve, and interact. It holds crucial clues to the origins of our own solar system and whispers hints about the potential for life in the dark, icy oceans of its distant moons. The story does not end here. In the coming years, humanity will return. NASA's ambitious Dragonfly mission aims to send a robotic rotorcraft to fly through the thick skies of Titan, searching for the chemical building blocks of life. As we look up at the night sky and spot that pale golden dot shining against the cosmic dark, we no longer see just a wandering star. We see a magnificent, swirling giant, a lord of rings and a keeper of moons, forever inspiring us to reach further into the great unknown.